Hey everyone, welcome back to another video on math past papers. Today we're going to talk about the P1 from the October-November 2024 series. The line L1 passes through point A minus 520 and the point B 3 minus 4. Find an equation for L1 giving your answer in the form y is equal to mx plus c. Okay, so just to have a little bit picture of how they're arranged, you have minus 520 somewhere over here, 3 minus 4 somewhere over here. So basically this is the line that they are expecting us. So this is your A, this is your B. Oh, sorry, it's not going to be crossing the origin. It's going to be somewhat like this. Or the other way, like around, but just something. Now, find an equation for L1. So, first things first, we need a form y minus y1 over x minus x1, and instead of just m, we can plug in y2 minus y1 over x2 minus x1. So, since this is a linear interpolation, so this is we can also do it this way. So let's plug in the values. So you have y minus, let's for x1 and y1 we can take, for example, this one. So you have y minus 20 x minus 5 equals to minus 4 minus 20 divided by 3 minus 5. So simplifying, y minus 20 x plus 5 equals to minus 24 over 8. This becomes 3 minus 3, sorry. So minus 3 is our gradient, so let's further simplify. Y minus 20 equals to minus 3 times y x plus 5, just simply taking this term on the right hand side. Now let's expand. So y would be equal to minus 3x minus 15 plus 20, simplifying further to y equals to minus 3x plus 5. So this would be basically, if we make it somewhat like this. Right, okay. Now that we've got L1, line L2 is perpendicular to L1 and passes through the midpoint of AB. So basically it's our perpendicular bisector. Find an equation for L2 giving your answer in the form this, where P, Q, and R are integers. Okay, so there are two things over here. We need the midpoint of A and B, and we also need a line perpendicular to L1. So midpoint of AB can be found by x1 plus x2 over 2, y1 plus y2 over 2. The coordinates that we have are minus 5 plus 3 over 2, and the y are 20 minus 4 over 2. So this is going to be minus 2 over 2, and this is 16 over 2, simplifying to minus 1 and 8. So this is our midpoint. Now what do we need? We need gradient of perpendicular line. So it's going to be the negative reciprocal. So we are going to use this principle, m1 m2 is equal to minus 1. So minus 1 over minus 3. So basically you will get 1 over 3. Now we can form another equation, y minus y1 equals to m x minus x1. This time we had m, so that's why we don't need it. So it's passing through this midpoint, so y minus 8 equals to 1 over 3 x minus minus 1. 3 can be taken on the other side. This can become 3y minus 24 equals to x plus 1. Everything on one side, 3y minus x minus 25 equal to 0. This is also correct, but since the other side is 0, we can multiply by negative on both sides, making it into x minus 3y plus 25 equal to 0. So both of these are our final answers. Either one of them can be right. Okay. Simplify fully 3y cubed 2x raised to power 4 cubed divided by 4x squared y raised to power 4. Okay. So first off, we need to do is to expand this one. So 2x 4 cubed can be expanded into 2 cubed times by x raised to power 4 times by 3. So this would be 8x raised to power 12. Now you have 3y cubed times by 8x raised to power 12 divided by 4x squared y raised to power 4. Now one easy way to handle this is bring the numbers on one side and deal with the variables, unknowns, separately. So you have 12 minus 2 and you have y 3 minus 4. So this would become 3 times by 8 divided by 4. 4 times by 2 is 8, so this would become 6 times by x raised to power 10 times by y minus 1. So this would be 6x raised to power 10 over y. Second part, find the exact value of a such that 16 over root 3 over plus 1 equals to a root 27 plus 4. So first off, let's deal with the left hand side. You have 16 over root 3 plus 1, just to make sure that we have the right thing right. Okay, so we rationalize by multiplying with root 3 minus 1 over root 3 minus 1. So the numerator just simply becomes 16 root 3 minus 16. Denominator becomes 3 minus 1, which is just 2. So 16 divided by 2, 16 divided by 2, this would become 8 root 3 minus 8. Now this is identical to a root 27 plus 4. Now one thing you know that root 27, since it is 3 cubed, 27, so it can be written as 3 root 3. Since we need it in the simplified form in root 3 form, we have to do that. So this would become 3a root 3 plus 4. So now what we need to do is we need to rearrange and make a the subject. So first 4 goes on the other side. 3a root 3 equals to 8 root 3 minus 8 minus 4, that becomes minus 12. So 8 root 3 minus 12. Now divided by 3 root 3. So a would be 8 root 3 divided by 3 root 3 minus 12 divided by 3 root 3. So for the first one, it just becomes 8 root 3. For the second one, 3 times by 4 and 1 over root 3 becomes 4 root 3 over 3. Oh, sorry, this is just 8 over 3. Sorry, my bad. Yeah, so that's your answer. So that's it. Your answer is A equals to 8 over 3 minus 4 root 3 over 3. Find the integral of f of x, where f of x is x plus 5 whole squared over root x. Okay, so first off, what we need to do is we need to rewrite f of x by first expanding the square. This would be x squared plus 10x plus 25 divided by root x on all the terms. And since we are familiar with the process of like how to work with indices, so this would become 2 minus half, that's 3 by 2, plus 10x, 1 minus 1 over 2 is 1 over 2, plus 25x minus 1 over 2. Now we need the integral. So this would be 3 over 2 plus 1 is 5 over 2. 5 over 2 over 5 over 2 plus 10 x 3 by 2 over 3 by 2 plus 25 x 1 over 2 1 over 2 plus 1. Now notice that all of these have 2, 2, 2, so they will go in the numerators. This will become 2 x 5 over 2 over 5 plus 20 over 3 x 3 by 2 plus 50 x 1 over 2 plus c. Simple, straightforward. Show that when f prime of x is equal to 0, this equation will be satisfied. Okay, so this time we have to take the derivative of that. So b1, f of x is same thing. Let's write it over here. 3 over 2 plus 10x 1 over 2 plus 25x minus 1 over 2. So f prime of x would be 3 over 2 x 3 over 2 minus 1 is just 1 over 2 plus 1 over 2 times by 10 x minus 1 over 2 plus 25 times by minus 1 over 2 x minus 3 over 2. So let's simplify before trying to make it into that form. So this one is fine. 3 over 2 x 1 over 2. This one is 5 x minus 1 over 2. 5 plus this would become minus 25 over 2 x 3 by 2. Now when we equate this to equal to 0, this would become entire thing 1 over 2 plus 5x minus 1 over 2 minus 25 over 2x minus 3 by 2 equal to 0. We need to make it into the form. So one thing we can do is multiply both sides by 2 to get rid of these denominator 2's. However, that won't be the only thing that we would be doing. We need to convert these powers of x into positive integers. So we need to multiply both sides by some power of x that can allow us to do that. So just to rewrite over here, we have 1 over 2 minus 1 over 2 and 3 over 2. Basically this is 0.5 minus 0.5 and minus 1.5. So let's try out what values we can increase it by. So if we increase it by just 0.5, 0.5 minus 0.5 plus 0.5 and minus 1.5 plus 0.5, this won't get us positive. So what about 1.5? So 0.5 plus 1.5, we don't need the one case over here because we need to turn it into integer. So all of these are 0.5, 0.5. So having another 0.5 would just having another 1 would get us back to 0.5 scenario. So we need a 0.5 addition, some form of 0.5, 1.5, 2.5, something to get it into an integer. So minus 0.5 plus 1.5 and minus 1.5 plus 1.5. So you will get 2, 1, 0. Now this is fine for us. So we multiply both sides by 2x 3 over 2. So we get 3x squared plus 5x minus 25 equal to 0. Let's see if that was the form that we needed. Oh, sorry, no. Oh, times by 10, times by 2, right? So that would be 10. Right. Okay. Hence state the value of x for which f prime of x is equal to 0. So we need to solve this quadratic equation. So x would be minus 10 plus minus b squared minus 4ac, 4 times by 3 times by minus 25, that is 300, so minus minus, plus divided by 2 times by 3, so this would become minus 10 plus minus 400 squared, 400 square root is 20 divided by 6, so one answer would be minus 10 minus 20 over 6, minus 30 divided by 6 would be minus 5. The other answer, minus 10 plus 20 over 6. 10 divided by 6 is a 5 over 3. So what was the condition again? X is greater than 0. So this means that therefore x would be equal to 5 by 3. Figure 1 shows a sketch of part of the curve C1, C2, given that C1 has equation y is equal to f of x, where f of x is a quadratic function, cuts the x-axis at origin, x is equal to 4, has a minimum turning point at 2 minus 4.8. Find f of x. Okay, so there are two ways we can do the first part. One, by doing completed square method. So completed square form. Since we just need f of x, we can do that way also. So general form of f of x can be written as ax minus b whole squared plus b, where b and c are turning points. They have given us turning point 2 minus 4.8. So this can be written as x minus 2 whole squared plus 4.8. Yeah, this is your 2 minus 4.8 are turning points. Singular. Now for a, the third unknown, we need to use either one of these. So f of 0 is 0 and f of 4 is 0. So basically we need to use these equations. So f of 0 is 0 and f of 4 is 0. So either one of them we can use. So let's use f of 4. So f of 4 would be equal to a 4 minus 2 would be just 2 whole squared plus 4.8 equal to 0. 4a equals to minus 4.8. This would be 4.8 divided by 4. This would be, oh sorry, this was minus 4.8. Sorry, this would be then minus, this would be then minus, just to make sure. Oh right, okay. So this would become plus, and right, so a would be just simply 1.2 or 6 over 5. This means your f of x is 6 over 5 x minus 2 whole squared minus 4.8. Okay, other method is using the form, general form, f of x equals to a x minus b x minus c, because they gave us two roots also. So that way you will have a x minus 0 x minus 4, which can be written as a x x minus 4. This is your f of x. Now to find out the third unknown again, you have to use the turning point form. So minus 4.8. So minus 4.8 equals to a 2 minus 4 is minus 2. Sorry, 2. So you have minus 4 on one side, minus 4.8 over here, which cancels out, leaving us a 6 over 5 again. So in this case, you will have f of x equals to 6 over 5 x x minus 4. Now depending on your choice, you can choose either one. Right, okay. Given that C2 has equation y is equal to g of x, where g of x is a cubic function, cuts the x-axis at the origin, meets the x-axis at 4. Now, cuts the x-axis, that means definitely x is equal to 0, but meets the axis, that means there are two duplicate roots at 4. As you can see over here, the curve is meeting, so that means x equals to 4 is a duplicate root. Okay, passes through 0.62. Now for this one, general form, what we can do is a x minus b x minus c x minus d. So we have all of them, x minus 0 and x minus 4 whole squared. So basically you don't have to write out the minus 0 thing. Now they gave us the turning point, which is 7.2. So g of 6 is 7.2. 7.2 equals to a 6, and 6 minus 4, 2 squared, which is basically 4. So a would be 7.2 divided by 6 divided by 4, or 7.2, 0.3. Or 3 by 10. So meaning your g of x can be written as 3 by 10 x x minus 4 whole squared. Now, the curves C1 and C2 meet in the first quadrant at point P1 shown in figure 1. Use algebra to find the coordinates of P. Okay. So notice one thing, that point P is not the only point where it's touching with the curves are meeting. They're meeting at x is equal to 0. They're meeting at x is equal to 4 also. So when we equate these together, now this time we have to use this form for f of x. So for the C part, 6 over 5 x x minus 4 and 3 by 10 x x minus 4 whole squared. We know that x is equal to 0 is already a solution and x minus 4 is already a solution. We just need the third one. So for the third one, we just need 6 times by 10, 3 minus 3 times by 5, that is x minus 4. 60 divided by 15 is 4, equals to x minus 4. So x would be equals to 8. Now we needed the coordinates, so we can plug in either one of them. X is equal to 8. So f of 8 would be 6 over 5. 8 minus 4. You will get 6 times by 8 times by 4 divided by 5. This is 192 over 5. So P would be 192 over 5. A plot of land OAB is in the shape of a sector of a circle with center O, given OA is equal to OB, 5 kilometers. Angle AOB is 1.2 radians. And find the perimeter of the plot of the land. Okay, so perimeter would involve OA, OB, and the arc length AB. So we need to find out the arc length. So arc length AB would be S is equal to R theta. So R is 5, theta is 1.2 radians. So 5 times by 1.2, that would be 6 kilometers. 12 times by 5, 60 basically. So perimeter would be 5 times by 2 plus 6, 16 kilometers. Now, point P lies on OB such that the line AP divides the plot of the land into two regions, R1 and R2, as shown in figure 2. Given that area of R1 is equal to 3 times by area of R2, show that the area of R2 is that. Okay. So, area of sector OAB is equal to area of R1 plus area of R2. Now they said area of R1 is basically 3 times the area of R2, and area of sector OAB can be written as half R squared theta, and 3 times by area of R2 plus area of R2. You can just simply write it as R2 also. I'm sure that would be fine. So this would be 25 times by 1.2 divided by 2, 15, equals to 4 times by area of R2. So area of R2 would be 15 over 4. Now 15 over 4 is 3.75 kilometer squared. Now find the length of AP, giving your answer to the nearest 100 meters. Okay, so what do we know? This is a part OB is part of OB. Okay, so we know R2, which is a triangle, so we can use half is equal to AB sine theta to figure out OP, and we already have OA. So once we find OP, we can use the cosine rule to figure out AP. We need AP, right? Okay. So no, this is part C. So area of R2 can be written as half 5 OP sine 1.2 radians. So this is 3.75 times by 2 divided by 5 times by sine of 1.2 radians equals to OP. Just to make sure, times by 2 divided by 5 divided by sine of this OP. So wait, 3.75 times by 2, 5 times by sine of 1.2. This is going to be 1.6094. Remember, we need this is an intermediate answer, so we need to use a better accuracy over here, so we can save it as an answer also. So now we need AP, so for that we can use cosine rule. So AP squared would be OA plus OP squared minus 2 times by OA times by OP times by cos of 1.2 radians. So this would be 5 squared plus 1.6094 squared minus 2 times by 5 times by 1.609 times by cos of 1.2 radians. So just to make sure that this is the answer, so 25 plus answer squared minus 10 times by answer times by cos of 1.2, we get 21.7584. So therefore AP would be the square root of the answer. We will get 4.664589 kilometers. So just times this by 1000, times this by 1000, we get, oh no, okay, so we get 4664, and we need it in the nearest hundreds, so this would become 4700 meters. Okay, so two significant figures are like the nearest 100 meters. Right. Okay. Question number 6. Sketch the curve C with equation y equals to 1 over 2 minus x. State on your sketch the equation of the vertical asymptote. Okay, so to do that, we have to remember how the reciprocal expressions are sketched. First off, if you do 1 over x minus 2, you can transform it by doing minus of 1 over x minus 2. So 1 over x minus 2 would be somewhat like this, where this is not supposed to be an arrow. Let's move it this way. So this is your x minus 2, but minus of that would turn the negative part into positive, and the positive part into negative. So this thing we can delete. So vertical asymptote, this is your vertical asymptote. X is equal to 2. And we also need this one, which is going to be x is equal to 0. So 1 over 2 basically. So this is 0, 1 over 2 is your y-intercept. So this is your y-axis, this is your x-axis. Okay. Straight line L has equation y is equal to kx minus 4, where k is a constant. Given that L cuts C at least once. Now, what does this mean over here? It means that when we equate the two equations together, 1 over 2 minus x equals to kx minus 4, and just to make sure that we have the right thing, minus 4 and 1 over 2 minus x. This would lead to a quadratic equation, and that quadratic equation will have determinant greater than equal to 0. Because when it is equal to 0, you have one solution. When it is greater than 0, you have two distinct solutions. So at least once would use both of them. So we cross multiply to expand and simplify. 2 minus x, kx minus 4. This expands to 2kx minus 8 minus kx squared plus 4x equals to 1. Now we need everything on one side, so kx squared minus 2kx minus 4x plus 8 plus 1 equal to 0. Now, just to make sure that we did the conversion correct, 8 is plus 1 minus 2kx minus 4x. Alright, okay. Let's further segment those. So this is 2k plus 4x plus 9 equal to 0. Now, the determinant b squared minus 4ac is greater than equal to 0. So this is your b squared. Minus won't be counted because the square would take care of the minus sign. Minus 4k 9 greater than equal to 0. So b squared minus 4ac greater than equal to 0. So this will become this. 4k squared plus 4 times by 2, 8, 16k plus 16 minus 36k. So greater than equal to 0. We get 4k squared minus 36 plus 16 is minus 20k. Greater than 0, we divide by 4 on both sides. We get k squared minus 5k plus 4 greater than equal to 0. Just to make sure that this is the correct form. Minus 5k plus 4. Right. Okay. Find the possible range values of k. So I don't think we have to do anything over here. This is just simple sum and product rule. So this is minus 5k. This is your x squared. This is your 4. So 4 and 1. But if they are negative, we'll still produce a product of 4, and sum is minus 4. So minus 4k, and sorry, this is k squared, and this is minus k. So you have k minus 4, k minus 1 greater than equal to 0. So another way to do the sum and product rule is that the roots alpha and beta would be equals to minus b over a, which is 5. What? Sorry, minus 5 over 1. So basically this would be equal to 5, and the product would be c over a, which is c over 1, 4. So if the product of the two roots is 4 and sum of the one is 5, so 4 and 1 would be those answers. So k is, these are the critical values, by the way, because you have a quadratic expression where this is 1 and this is 4. We need greater than equal to 0, so we need a region lower than 1 and greater than 4. So therefore k is either less than equal to 1 and k greater than equal to 4. And that's about it. Right. Figure 3 shows a plot of part of the curve C1 with equation y is equal to minus 4 cos x, where x is measured in radians. Points P and Q lie on the curve and are shown in figure 3. State the coordinates of P and the coordinates of Q. Okay. So, cos x means that the period is still 2 pi. So, this point over here would be 2 pi, but this one would be at minus 2 pi. And minus 4 part means that this is minus 4, so this would also be minus 4. So P would be A part 1 would be minus 2 pi minus 4. Right, and Q. So Q is, let's say this is pi by 2, this is your pi, this is your 3 pi by 2, and 2 pi. So 3 pi by 2, 0. Okay, so the curve C2 has equation y is equal to minus 4 cos x plus k, where x is measured in radians and k is a constant. So this factor introduces translation. Given that C2 has a maximum y value of 11, state the value of k. So over here the maximum value was 4. And now if it's going to 11, so 11 minus 4 would be just simply the answer, which is going to be 7. So state the value. So max value translation goes to 11 minus 4, 7. So therefore k is 7. State the coordinates of minimum point on C with the smallest positive x coordinate. Okay, so it would be 11 minus 8, because peak to peak is 8 units. So if the new maximum is 11, new minimum would be 11 minus 8, which is just 3. Y value would be 3, but x value minimum would be, we needed the smallest positive, right? Smallest positive. So it's just simply vertical translation. So smallest positive x coordinate. So this would be this one, 2 pi and 8. Right, okay, B part 2 would be y coordinate would be 11 minus 8, which is 3, but the coordinate that we are looking for is 2 pi 3. Okay. On the opposite page, there is a copy of figure 3 labeled diagram 1. Using diagram 1, state the number of solutions of the equation 5 minus 10 over pi x, giving a reason for your answer. Okay, so the equation is 5 minus 10 over pi x. Now this is a straight line because this is your C, this is your M and X. Okay, so we need to gently sketch it and see how this goes. So 5 would be the what was I going to say? Yeah, 5 would be the y-intercept. Okay. Now we need, for example, this one. This was your 2 pi. No. 3 pi by 2 over 0. We need to see where the graph is over here, or we can see it at 2 pi. Or we can even see that at pi, because you have a 10 pi over here. So we can do y at x is equal to pi. You will have 5 minus 10 over pi times by pi. This would be basically 5 minus 10, which would be minus 5. So at pi, which is the half value over here, your point is over here. So this is your sorry, let's try again. You have this. This is your line. And yeah, I think it's touching it at pi over 2. So if you take x as pi over 2, you will have 5 minus 10 over pi over 2. So pi gets cancelled, and 5 and 5 would also get cancelled. So we are actually very good. So only one solution. Wait, sorry, where did it go? Giving a reason for your answer. State the number of solutions. Okay, so only one solution. Is this part D or C? C. Only one solution corresponding to one point of intersection at coordinate, and the coordinate was x is equal to pi by 2, 0. That's it. A curve C has equation y is equal to f of x. Point P with x coordinate 3 lies on C. Given that f prime of x is this, where k is a constant, and the normal to C at P has equation this. Show that k is equal to minus 5. Wait. So point P with x coordinate, 3 lies on C, and the normal to C. Okay, so this is the gradient of the normal. So gradient or tangent, or so we can say gradient of C at P is 24, the negative reciprocal of minus 1 over 24. So now we can do f prime of 3 is just 24. So 4 3 squared plus k times by 3 plus 3 equals to 24. So 4 times by 9, 36, plus 3k plus 3 equals to 24. So 3k would be 24 minus 39. 24 minus 39 minus 15 divided by 3. Oh, sorry, I didn't need to do that. So minus 5. Hence, find f of x. Okay, so we need to do Okay, so normal to C at P would also get us the y coordinate of point of this. So y value at x is equal to 3 would be y is equal to minus 1 over 24, 3 plus 5. The minus 3 divided by 24 plus 5 is 39 over 8. So minus 1 over 8 and right. Okay, so this is the point where f of x is passing through. Okay, so we need the integral of f prime of x dx. This would get us 4x squared, so 4x cubed over 3 plus kx minus 5x squared over 2 plus 3x plus c. And what do we need now? X is equal to 3, y is equal to 39 over 8. So we plug this in. This is your y basically. So 39 over 8 equals to 4 over 3, 27, minus 5 over 2, 9, plus 3 times by 3 plus c. So c would be equal to 39 over 8 minus 4 times by 27, 108 over 3, 36, plus 45 over 2 and minus 9. So just to make sure that this thing is subtracted, this thing is added, and this thing is subtracted. Okay, so 39 divided by 8 minus 36 plus 45 divided by 2 minus 9, that is minus 141 over 8. So your y, or f of x, is 4 over 3x cubed minus 5 over 2x squared plus 3x minus 141 over 8. Figure 4 shows a sketch of the curve C with equation y is equal to f of x, where f of x is x plus 5 times by 3x squared minus 4x plus 20. Okay. Deduce the range of values of x for which f of x is greater than equal to 0. So basically this is the part. So this is the minus 5. This would get us complex roots, unreal roots, sorry, not real roots. So that is why this point is not, there is no other x crossing over here. So the only real coordinate or real root is minus 5. So this would be x greater than minus 5. Okay. Find f prime of x, giving your answer in the simplest form. Okay. So for that we need to multiply this first. So your f of x is x plus 5, 3x squared minus 4x plus 20. So 1 by 1, 3x cubed minus 4x squared plus 20x plus 15x squared minus 20x plus 100. So this would be 3x cubed. 15 minus 4 is 11. X squared. 20x gets cancelled. Right, and then we have plus 100. Okay, we need f prime of x. So f prime of x would therefore be 3 times by 3x, 3 times by 3x squared plus 2 times by 11x plus 0. So this would be 9x squared plus 22x. Right, okay. The point r minus 4, 84 lies on C. Given that the tangent to C at point P is parallel to tangent to C at point R. Wait, where is P? Point R lies on C, given that the tangent to C at point P is parallel to tangent to C at point R. So that means at point R, whatever the tangent, it is also the same at P. So basically we need to figure out how many times, like how many x values will the tangent be repeated. So first off, we need to find f prime of minus 4. So 9 times by minus 4 whole squared plus 22 minus 4. This is 9 times by 16 plus, actually minus 88, 56. Right, okay. Now we need to see how many places do we get 56. So 56 equals to 9x squared plus 22x. So this simplifies to 9x squared plus 22x minus 56 equal to 0. We need to solve this quadratic equation. So minus 22 plus minus 22 squared minus 2 times by 9 times by 56 square root divided by 2 times by 9. So we are getting 22 squared plus 2 times by 9 times by 56, 1492, the square root of which is this value. So minus 22 plus minus 2 root 373 over 18. So I hope we are getting at least one of them to be minus 4. So plus 2 373 divided by 18, 0.9. So minus 22 plus 2 373 over 18, which is 0.924, let's say. And the other one, let's hope, fingers crossed, minus 3.36. Okay, that means we made a mistake somewhere. So at minus 4, wait. Minus 4. So 9 times by 16 plus 22 times by minus 4, 56, that is correct, minus 56, 4AC, 4AC, oh, sorry, my bad, I made a mistake, 4AC. So going back to, okay, this is gone. Okay, never mind, I can rewrite it. So minus 22, so this one is incorrect. Okay, so minus 22 plus square root of 22 squared minus 4 times by 9 times by 56, and the other is 18. So plus 14 over 9. Sorry. Okay. So one answer is 14 over 9, and the other answer would be minus 4. So 14 over 9 is the answer, and we need the x coordinate of p, that is p x. So x coordinate of p is 14 over 9. Okay. Find the point to which r is transformed when the curve with the equation y is equal to f of x is transformed to the curve with equation y is equal to f of x minus 3. Okay, so this is horizontal translation, which can be written as 3, 0 vector, and 4 f of x is basically 4 xy. X times y, x 4y, whatever this is, will be transformed this way. The y value will be transformed this way. So for the first one, we need r, which is minus 484. So dot. So translation vector is 3, 0. So r would be transformed to transformed point. Let's say r prime would be at minus 4 plus 3 minus 1. 84, and the other one would be at vertical scaling by a factor, vertical scaling or a stretch by a factor of 4. So this would be, r prime would be at minus 4, 84 times by 4, this is 336. And that's about it. And yeah, thank God. Okay, alright, it's over. Alright, so that was the last question. If you have any questions or doubts or any comments, reach out to us using the comment section. If you like this video, give us a thumbs up, subscribe to our channel, and turn on the notifications for future updates. If you would like us to do a specific paper, you can also request that in the comments. Meanwhile, take care. We will see each other in the next video. Bye bye.